MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject, analog devices and circuit. Unit number 1, analog electronics. So last class we discussed with the different switching devices like ACR, TRIAC, JFET and MOSFET. So like that we discussed about difference between the JFET and MOSFET and ACR and TRIAC, like that we discussed in the last chapter. So in this class, we are going to know about the rectifiers. Okay, generally, we know that rectifier is called as converts analog signal into the digital signal, that is AC current into the DC current. Okay, using the diode format. Okay, so we know that diode always conduct the open circuit for the reverse bias, closed circuit for the forward bias. So that condition here we are going to perform through the diode and the resistor. Okay, so here rectifiers having three types. One is half wave rectifier, full wave rectifier, and bridge rectifier. Okay, so the rectifier data. So how the rectifier converts the input into the output, that is called a ripple factor. So ripple factor of the half wave rectifier is very low. Full wave rectifier is 80%. So bridge rectifier, it is greater than the full wave rectifier. Okay, that means how we are converting the input data into the correct output data. So in rectifier, half rectifier, we are going to cut the negative signal. Okay, we know that normal AC wave will be up and down through the positive and negative. So for this condition, so in half rectifier, we are cutting the negative portion. So you will get the positive portion. So it will be a direct wave. So like that, we are using the rectifiers. How far we are converting the data, that is how far we are reject the data, like that the ripple factor will define. So let's see the definition of the rectifier. A rectifier is an electron device that converts alternating current, which is periodically reverse direction, to the direct current, which is only one direction. A process known as rectification. So there are three types: half rectifier, full wave rectifier, and bridge rectifier. In half rectification, so either the positive or negative half of the AC wave is passed, while the other half is blocked, because only one half of the input waveform reaches the output. Because only one of the input waveform reaches the output. It is very inefficient used for the power transfer because we are cutting the data. Okay, now we are remove the negative side. So it will be a less efficiency in the output. So this is the AC input. So when positive cycle, the circuit will allow the output. When negative cycle, the cycle will not be allow the output, because at that time the diode will be open circuited. Okay, this is the basic model. So this output are nearby equal to the positive side. So it is called a half wave rectifier. This is a model. Okay. Full wave rectification, that is derived from the half wave rectification. So that is for single phase AC, if the transformer is transconductive, then two diodes back to back, that is anode to anode or cathode to cathode, can form the full wave rectifier. That means, so here we have two diodes. Here we have D1 and D2. When positive cycle, so when positive cycle given to the circuit, that diode D1 is on. This one is off because it is a reverse biased. So because center tapped transformer, so if it is here positive means it will be a negative. Okay, so that concept here used, so you will get the output of 1. Okay, so when you are giving negative signal to the this side D1, so this one is open circuit. So if it is negative means it will be positive. Okay, so that means this negative signals also be like this because positive. So that positive means it will be given to the D2. Okay, but directly D2 will be go to the output. So again you will get a positive cycle. So this is the one of the best method for converting the AC signal to the DC. நீங்க கேட்கலாம். So why, sir, this is not a DC signal, it is always varying in the negative positive side, sir. How you can say as the uh, DC. Okay, hereafter they are connected to the capacitor. Okay, so using capacitors, we can convert this like this. That is variations of the circuits. So that means, so the range of output will be varying with respect to the state line. So small variations in the side. So it will be very effective transformation of AC signal to DC signal. So that is bridge rectification. That is also called the full rectification. So in a circuit with a non-center tapped transformer, 4 diodes are required instead of the one needed for half rectifier. So in this circuit, they are using 4 models, 4 diodes to get the output of full rectification. Okay. So when I give positive signal, okay, if I give positive signal means, so let's see. So this one is enabled. Okay, this one is positive, this one is negative. Okay, what will happen? So this one is positive, so you will get a more output in this. So negative means it will be reverse direction, so you will get in the output. So see the animation. Okay, in second half, in negative circuit, see this is positive, so negative will go through this line, and positive go through this line. This is the concept of bridge wave rectification. Okay. Okay, these are the 3 concepts used in the model. So how to calculate the output DC voltage with respect to the input? Because the average and the root mean square of the output voltages of an ideal single phase fully rectifier can be calculated as VDC is equal to VAV is equal to 2VP divided by pi. That is VRMS is equal to VP divided by root 2. So this is the concept for the full wave rectification. So this is the output because we will get the DC voltage like this. So bridge rectifier makes use of the 4 diodes in the bridge arrangement to achieve full wave rectification. So same concept. நம்ம அங்க சொன்ன மாதிரி தான். The full wave rectification concept தான் திருப்பி explain பண்ணிருப்பாங்க. Okay. So here also see the diagram. So that is red color, it's a forward bias. Black color is a reverse bias. Okay, so this class enough. So next class we will see the filters and the rectifiers, filters and the regulated power supply and SMPS like that we will discuss in the next class. Thank you.